This video is brought to you by mywayteaching.com.
Next concept is enthalpy change, delta RH of a reaction, that is reaction enthalpy. Okay, so the enthalpy change accompanying a reaction is called reaction enthalpy. Accompanying a reaction, this is called reaction enthalpy. Okay, so in a chemical reaction, reactants are converted into products. That is, we know that these are reactants. Okay, they are converted into products. The enthalpy change accompanying a reaction is called reaction enthalpy. Okay, so the enthalpy change of a chemical reaction is given by the symbol delta RH. This is given by the symbol delta RH. Delta RH is equal to, we can write delta RH, that is equal to sum of enthalpies of product minus sum of enthalpies of reactants, that is sum of enthalpies of products, that is H products minus summation bi H reactants. Okay, so here sigma, this is the symbol, is used for summation, and A and B are the stoichiometric coefficients of the products and reactions respectively in the balanced chemical equation. Okay, so this is the enthalpy change. So example, note down the example, I will write here, that is methane CH4 plus oxygen. This gives carbon dioxide plus 2H2O liquid. Okay, so delta RH is equal to products minus reactants, that we know, that is summation of products minus summation of reactants. So HM of carbon dioxide, this is gram plus, okay, where HM is the molar enthalpy. HM is equal to molar enthalpy. Enthalpy change is a very useful quantity. Knowledge of this quantity is required when one needs to plan the heating or cooling required to maintain an industrial chemical reaction at constant temperature. It is also required to calculate temperature dependence of equilibrium constant. Okay. Next concept is standard enthalpy of reaction. The standard enthalpy of reaction is the enthalpy change for a reaction when all the participating substances are in their standard states. So the standard state of a substance at specified temperature is its pure form at 1 bar. For example, consider the standard state of liquid ethanol at 298 Kelvin is pure liquid ethanol at 1 bar. Standard state of solid iron at 500 Kelvin is pure iron at 1 bar. Usually data rate taken at 298 Kelvin. So standard condition are, this is over example. So this is standard conditions are denoted by adding the subscript. Okay, you remember this subscript is used everywhere. Okay, in the next coming topics to the, this is subscript to the, this is the subscript, okay, to the symbol delta H. Example, if you are this as a delta H, this is standard, this is called standard condition. Okay, next, this is standard enthalpy of reaction. Note down this standard enthalpy. Standard enthalpy of reaction is the enthalpy change for a reaction when all participating substances are in their standard states. Okay, next, enthalpy changes during phase transformations. The change, the enthalpy change that accompanies melting of 1 mole of a solid substance in standard state is called standard enthalpy of fusion or molar enthalpy of fusion. So remember what is the standard enthalpy of fusion or molar enthalpy of fusion. Okay, next, amount of heat required to vaporize 1 mole of a liquid. See, 1 mole of a liquid, okay, at constant temperature and under standard pressure is 1 bar. That is called its standard enthalpy of vaporization or molar enthalpy of vaporization. See here, this is the standard enthalpy of fusion. It means change in the enthalpy change that accompanies melting of 1 mole of solid substance in standard state. 1 mole of solid substance melting. It is called standard enthalpy of fusion or molar enthalpy of fusion. Melting, if it is melting means that is called enthalpy of fusion. So if it is vaporizing at constant temperature and at standard pressure, so that is known as enthalpy of vaporization. Okay, next coming to the point, standard enthalpy of sublimation is, okay, is the change in enthalpy when 1 mole of a solid substance sublimes at constant temperature and standard pressure, that is 1 bar. Okay, so this is standard enthalpy of sublimation. And you should know that all these things, what do you mean by standard enthalpy of fusion, standard enthalpy of vaporization, standard enthalpy of sublimation. Okay, next, this is standard enthalpy changes of fusion and also vaporization. Okay, next, coming to the what is, these are the substances, okay, and what is the TF and fusion and then vaporization values. Next, problem. Consider the problem. A swimmer coming out from a pool, he is covered with a film of water about 18 gram. Okay, how much heat must be supplied to evaporate this water at 298 Kelvin? Calculate the internal energy of vaporization at 100 degrees Celsius. And they are have given, and also this is also question for water at 373 Kelvin is equal to 40.66 kilojoule per mole. Next, I will solve the I will solve it. We can represent the process of vaporization. H2O, that is in liquid, vaporization, that is 18 gram of H2O, water in gaseous, which is, okay, so number of moles in 18 gram, 18 gram liquid is per mole equal 1 mole. Okay, so delta, this is vaporization, change in vaporization enthalpy, change in vaporization, standard enthalpy change minus P into delta V and G into RT, assuming steam behaving as an ideal gas. Now delta is it minus delta Ng R into T is equal to 40.66 kilojoule per mole. Okay, we know this value, and what is this value? Substitute minus here, and this value is we'll write 1314 kilojoule joule. Okay, uh, so 8.314 joule per kilo per mole into 373 Kelvin 10 raised to minus 3 kilojoule per mole. So delta vaporization, this is standard 40.66 kilojoule per mole minus 3.10 kilojoule per mole is equal to 37.56 kilojoule per mole. Next is standard enthalpy of formation. The standard enthalpy change for the formation of 1 mole of a compound. Standard enthalpy change for the formation of 1 mole of compound from its elements in their most stable states of aggregation is called standard molar enthalpy of formation. Is called standard, and its symbol is its symbol is this one. So this is standard enthalpy of formation, means 1 mole of a compound. If you take 1 mole of compound from its elements in their most stable states of aggregation, he is called standard molar enthalpy of formation. Okay, next is, suppose you are a chemical engineer. Okay, next consider you are a chemical engineer and want to know how much heat is required to decompose calcium carbonate to lime and carbon dioxide with all the substances in their standard state. So calcium carbonate, okay, that is in plus carbon dioxide. Okay, here we can make use of standard enthalpy of formation and calculate the enthalpy change for the reaction. The following general equation I will write here can be used for the enthalpy change calculation. We know that this is summation I ai into delta f, this one, that is called products, minus summation I bi into delta f into reactants. Okay, so when a and b represents the coefficients of the products and reactants in the balanced equation, let us apply the above equation for decomposition of calcium carbonate. So here coefficients a and b are 1 each, therefore delta r h theta is equal to delta f Okay, you just write down the products here: calcium oxide plus delta F. This is carbon dioxide, calcium carbonate. Okay, next, substitute value, that is 1 minus 635.1 kilojoule per mole plus what is delta F of a H, that is standard enthalpy of fusion, is 1 only, minus 393.5 kilojoule per mole. Okay, next one is minus 1 minus 120.6.9 kilojoule per mole. So you are getting 178.3 kilojoule per mole. So thus the decomposition of calcium carbonate is an endothermic process, and you have to heat it for getting the desired products. Decomposition of, therefore, thus decomposition of calcium carbonate is an endothermic process. Okay, this is an endothermic process.